Okay, so the next question is 6.16. Actually, it is 6, it is not 10. Arrange the compound in each set in order of reactivity towards SN2 displacement. That means they are asking whatever compound they have given, you are supposed to arrange them in increasing order. That means decreasing order. Who will react faster to the smaller? So these are the three questions. So you will not able to do this question until you draw the structure. So let me just draw the structure. Before that, let me just give you a quick thing about SN2 reaction. SN2 reaction takes place in one step. Remember it. SN2 reaction when it is acted, back attack takes place. Next, the reactivity order depends on the steric hindrance. Less the steric hindrance, more quickly it will able to attack it. Okay, so here out of these three, let's see which criteria will work. There are more 10 point, but I think steric hindrance will work here because they have given the same type of compound but different one can say isomers of it. So let us draw 2 bromo 2 methyl butane. It is methyl. Okay, so 1 2 3 4. So this is 1 2 3 4 butane, 2 bromo. So here there is a bromo and 2 methyl. So there is a CS3 group. I'm not drawing the what we can say hydrogen and all. Just you have to remember because we have to understand the clarity of it. Okay. Then one bromopentane. 1 2 3 4 5 and one bromo is here. And then next is 2 bromopentane. 1 2 3 4 5 and 2 bromine here. Now, who will react faster? They are asking this one. So first find out the carbon in which bromine is attached, which degree carbon it is. Now if you see bromine is here and the carbon which is attached to this bromine is attached to how many other carbon? 1, 2, 3. So this is a 3-degree carbon. Next, if you see at this carbon, this is attached to only one, so it is a 1-degree carbon. But look at this, the bromine which is attached to this carbon is attached to two other carbons, so it is 2-degree carbon. And if you see here, nucleophile want to attack. If you see here, when it comes here, because obviously bromine will leave, there's too much interaction. One CH3 here, then one C2H5, too much steric hindrance. So 3-degree for sure will have the minimum, I will say, that it will be very difficult for attacking this one, right? So 3-degree, this is minimum. Then nucleophile will not prefer this 2-degree also because here again there are two groups, then 2-degree and then 1-degree. So this is the order we know, right? As per steric hindrance. Now as per this question, who will come first? Now if you see here, 2 second carbon, which is 1 bromopentane. 1 bromopentane. It will react fastest. Then 2 bromopentane. So you have to write in this way. And then it will be 2 bromo 2 methyl butane. I hope you understood this. I will give you the ideal answer, but just gave you the concept. And the reason what you will write is that in SN2 reaction, the reactivity depends on steric hindrance. More the steric hindrance, slower the reactivity. So you can remember steric hindrance is inversely proportional to reactivity. Now same thing you have to do for second question. 1 bromo 3 methyl butane. So let us draw 1 bromo 3 methyl butane. So 1 2 3 4 4 bromo हो गया, 1 bromine here, 1 bromine, 3 methyl. So 1 2 3 here, 3 methyl. Okay, this is your first structure. Moving on, 2 bromo 2 methyl butane. So 1 2 3 4 2 bromo, so 2 bromine and 2 methyl. This is your second structure. And third one, 3 bromo 2 methyl butane. So again 1 2 3 4. Now 2 bromo 2 methyl. Okay, here 3 bromo here. Okay, 2 bromo 3 methyl. So from here on we'll do counting. Okay, so these are the three structures. So again what we'll do, check the order. This is your bromine which is attached to the carbon, is attached to how many carbon? 1. So this is a 1-degree. Next, this is the bromine attached to this carbon, it is attached to 3 other carbons, so it is 3-degree. So this is the bromine attached to this carbon, attached to 2 other carbons, so 2-degree. So what do you think? The minimum steric hindrance where it will happen? Obviously here. So 1 bromo 3 methyl. So let me give you just this as ABC instead of writing the name. You write the name in the exam, but I'm just going to say A. If you see, will have maximum 1 bromo 3 methyl butane. Then 2-degree here, 2 bromo 3 methyl butane. So C. Then after that B, which is 3-degree. So this is your order for reactivity in second case. Now let's move to the third case. Okay, so now let's see the third one. Remember, the third one is most important question out of all these three. The reason is, let me draw the structure, then it will become more clear. One bromobutane. So one, two, three, four, and bromine here. Okay. B1 here is one bromo 2,2 dimethyl propane. So what is the structure? First you draw a propane. One, two, three. Okay. One bromo. So a bromine here. 2,2 dimethyl. So one carbon here, one carbon here. C1. One bromo 2 methyl butane. So 1, 2, 3, 4. Again bromo 2 methyl means here. CS3 is there. Okay. So here CS3 is there. I'm just showing for the alkyl group. Next we have is one bromo 3 methyl butane. So 1, 2, 3, 4. 1, 2, 3. Yes, CS3. Now we have to find the winner. These all four are running for SN2 reaction. Where the nucleophile? Nucleophile is like, swamber where bride will select the groom. Now which groom she will select depends on has the minimum steric hindrance. Who is having minimum red flag, right? Now look here. This is the nucleophile. Now you think first let us decide the degree. So this is one carbon 1 degree only. And here also if you see this is 1 degree. Here also this is 1 degree. Here. So there is no problem of here 1 degree, 2 degree, 3 because all are 1 degree now. Now how to compare in 1 degree because all carbon which is attached to the halogen here is 1 degree only. So now you have to check the next one which is the beta one. Which one is having free beta? If you see obviously there is no one here. So A is the winner for sure. Who is the second runner up over here? Now if you see this is your beta carbon has two substituents. So it is more crowdy, right? You can see it. Here if you see here beta itself has one CS3, but here you see beta is free and gamma is having a you can see a what we can say a group which is a substituent. So nucleophile will prefer the second one here because it is more free, no? So here D will be the next answer. Then obviously here C, and at last too much crowded here is B. So the minimum reactivity will be for B. So I hope you understood this. Let me show you the ideal answer for all of them. So you are supposed to do first this in exam. First draw the structure of all, draw their name, find out the degree, and then write the name as a order. So this is the ideal way you are supposed to do. I have given you the concept, how concept you will apply and how you will able to get the answer. Then this part is to just draw the structure, write the name and arrange them. Simple. I hope you understood. Thank you.